Hello everyone, Gaza Motkarsh, and I welcome you all to this session on data cleaning and pre-processing. So guys, let's have a look at the agenda for this session. So the agenda for this session includes detecting and handling null values. Then we'll look at the different methods to handle the null values, and we'll also look at how to handle duplicate records in the data frame. So in the sessions prior to this session, we have discussed the difference between series and data frames. We have covered and implemented various data frame operations and functions. Besides that, we have also discussed how to read and write onto a CSV/Excel files. So guys, let's switch to the Jupyter screen. So guys, over here we are into the Jupyter screen, right? Now the agenda is to, let's say, understand data cleaning, especially in terms of handling missing values and handling duplicates. So first things first of all, we need to import NumPy and Pandas. Over here I've imported Pandas as PD, and then I've imported NumPy as NP. So we have to read a dataset that contains missing values, and only then we can try to, let's say, figure out different approaches to, let's say, detect and even treat missing values. So first of all, I'll be reading a data frame. So I have a data frame called data1. So pd.read csv, it is a csv file, data1.csv, right? So now if I show you the data frame, as you can see, this is the data frame, right? So what all columns do we have? We have age, income, score, height, expenses, debt, gender, city, education, job, and marital status. These are the columns that we have. Let's have a look at the shape of the data frame. So the shape that we have over here is 40, 11. We have 40 rows. The number of rows that we have is 40, and the number of columns that we have over here is 11. So this is our data frame. Now we can also look at the columns. So df.columns. Alright, this generates the list of different columns that we have, and we have 11 columns in total. So this is the data frame. Now over here we can see a couple of NaN. Now NaN indicates that the data contains null or missing values. So there can be multiple rows into which we can have null values. Alright, so we have to treat them accordingly. We'll treat the data accordingly. So as you can see, there are a couple of columns that are numerical. For instance, age, income, score, height, expenses, and debt. These are numerical features. Then whereas we have gender, city, education, job, and marital status, these are categorical features. So the method to treat these columns also varies. All right, the method also varies. So first of all, before proceeding to handling the missing values, we must be in a comfortable position to detect them first. So for detection of let's say null values, there are two different approaches. We can write, the data frame name is df, right? We can write df dot is null dot sum. So over here, as you can see, we do have, it displays, what does it return? It simply returns column wise sum of null values, right? It returns column wise sum of null values. There is yet another approach of implementing the same. Over here I can write df dot is null dot sum. All right, over here I can write df dot is null dot sum. Is null, okay, I've written is null over here. This would be is na. So when I write is na dot sum, even this function returns column wise sum of null values. Now at times just finding or figuring out the sum of null values for each column is not sufficient. At times we may also need to find the percentage of null values out of the total number of rows. All right, so over here we need to find the percentage of null values as well. So for that, we'll be converting this output, which happens to be a series, into a data frame. So next we'll, let's say, figure out a function to find count and percentage of null values. So over here, let's call the function as count and percentage of null. And for any data that I pass, I'm creating a variable called nv. All right, nv, let's say, is null value. So nv is data dot is null dot sum. Now what is data that I've passed over here? The data that I passed over here is nothing but the data frame, right? Now I have to filter nv such that I need only those records where nv is greater than 0. What does this imply? Filter all records where count of null is greater than 0. All right. Next we have to understand this. So over here we have this series. Now from the series we have filtered all the records where the count of null values is greater than 0. Now if this is a series, so this becomes the index and this becomes the value. Let me store this in a variable and I'll show you. nv. Now for this nv, if I print the index and value nv dot index, so it returns the column names, and if I print nv dot values, what do I get? I do get these numbers. The numbers were the count of the missing values, right? So this is what we have obtained. We have obtained the index and we have obtained the values. So now as far as this function is concerned, we have to create a data frame that displays count and percentage of null values for each of the features. These are the columns, right? So how can I do this? Over here I'll be writing nvdf. nvdf is just a name that I came up with. nvdf का मतलब है null values का data frame, right? Simply put. So pd dot data frame, इसके अंदर I'm passing the first column would be feature. Feature is nothing but the column name. So column name, how can I fetch it from the nv? Using nv dot index. So nv dot index से हमें feature name मिल जाएगा. Then अगर हमें इसका count निकालना है, so how can I fetch the count? Count would be nv dot values. Alright, the count would be nv dot values, and then अगर हमें यहाँ पे let's say percentage of null values निकालना है, percentage would be count upon total number of rows. Total number of rows is 40. So how can we obtain 40? Okay, if I write like this, df dot shape 0, over here we have obtained 40, right? So I can write it over here. यहाँ पे हम इसको लिख सकते हैं that this is the percentage of null values would be, let me write this in the next line. How can I write the percentage of null values? Nv dot values divided by data dot shape 0. Why shape 0? Because I only need the rows, and then I can convert this to percentage. So I just need to multiply it with 100. Alright, and then we have nvdf. So from this function I can return the nvdf. Also I can sort nvdf. Why do I need to sort? So that I do get to see which columns has highest percentage of null values. So I'm sorting it based on percentage in the descending order, right? So I'm sorting it based on the percentage in the descending order. So guys, once we have applied this function, we have created this function. Observe this step by step. So percentage is nv dot values upon data dot shape 0 into 100. And this is how we have sorted the data based on the descending order of percentage. Now, once I'm returning this function, so I can just write nvdf. This is the function called the data is df, and I can display nvdf. So if you observe this, job has let's say maximum number of null values, that is 17.5%. Then score has 12.5% null value, city has 12.5, education has 12.5, income debt has 10% null values, age and marital status has 7.5% null values, height is having 5%, gender 5%, and expenses only 2.5%. So this is the count and percentage of null values. Now guys, we have read all the null values. Now we know which columns contains how many null values and its percentage as well. So moving forward, we have to discuss the methods to treat null values. So guys, the methods do vary. Okay, I'll list all the methods. The first method is to drop the rows containing null values. Second method is drop the columns containing the null values. The third method is fill the null values. Now, when we are filling the null values, there are let's say multiple approaches. Now, if let's say if feature is categorical, if the feature is categorical, all right, then we can. So this filling the null values, this method is referred to as imputation. This method is referred to as imputation. All right. So let's see this in action. So using imputation, we can fill the null value. So if the feature is categorical, we can impute with mode, or let's say some fixed value. Some fixed value, for instance, for example, maybe unknown / other. All right. And if feature is continuous, then we can proceed with impute with, we can impute it with mean or median, at times with a fixed value, with a fixed number, all right, with a fixed integer / float, These are also the options. Now if feature is, let's say, time series data, then we can proceed with, let's say, bfill or even ffill. Ffill is forward fill and bfill is backward fill. The ffill is forward fill and the bfill that we have over here is the backward fill. So these are the different options. Now besides this, at times we can also use interpolate. We can use the interpolation method as well. So guys, these are different approaches to treat the null values. All right. Yeah, so just observe this. We can drop the rows containing the null value, we can drop the columns containing the null value, or the third method is imputation, where we fill the null values, right? So if the data is categorical, we impute it with mode, or let's say some fixed value. For instance, it can be unknown or other. If the feature is continuous, we can let's say impute it with mean, median, some fixed integer or float, or we can apply the interpolation method. And if the feature is time series data, we can use bfill or ffill approaches. So let's implement them one by one. So this is the data frame, right? The data frame is df. Now I'll be creating a couple of copies of data frame. So df1 is df.copy. Why are we creating the copies? I'll just tell you. Then I'll be creating df2, df3, and maybe df4. So we are creating copies so that if we make changes in any one of these, if we make changes in df1 is not going to get impacted. Likewise, if we make changes in df2, 3 or 4, none of them are going to get impacted. So we'll have separate copies of each data frame. All right, each copy independent of the changes made to the other. So if I make some changes, suppose I, let's say, drop few rows, drop few columns, so it won't be impacted in others. Let's see the first method, drop the rows containing null values. So I'll be applying this in df1. All right, let's drop the rows containing, let's drop rows and columns containing null values. Now it's imperative to understand when to use this approach. So when would we drop rows or columns containing the null values? We drop the rows containing null values if the percentage of records, all right, if the percentage of null values in that column is very low. For instance, if I want to drop rows containing null values, so I would only drop in expenses because it only contains 2.5% of null values. All right, so maybe I can drop, but we have to treat other columns as well. All right, before dropping this, we have to treat other columns as well. All right, so we have to drop the rows. So we do have a function df dot drop na. Now currently if I use this, it is going to drop all the let's say rows that contains the null values. So let's see if we do have any function argument. All right, so we do have subset. So using subset, if I use subset, so what is the subset that I want to pass? Expenses. Let's see if it works. All right, and over here I'll have to write in place is equal to true. So once I've executed this, now there should be no null values in the expenses column. Let's check this. So maybe we can call this function again, right? So first of all, we have seen how to drop the rows containing the null values. Likewise, we can apply it to other columns as well. So guys, if you observe, now we are not getting any null values in the expenses column. We can also check it like this, df.isNull.sum. All right, expenses column, we don't have any null values. Now if we were to check other columns that contains null, so besides expenses, we can also drop, let's say, we can also drop the null values in height and gender because we only have 5% null values. So let's drop null values from the number of rows containing null values from height and gender. So what are we going to write? This is, let's say, drop rows containing null values from, what is the column? From expenses. Correct. So this is one option. Now let's see another example for the same. Drop rows containing null values from height, gender and height. Why are we using this approach? Okay, currently we are only dropping rows, right? When do we use it? Used when, let's say, percentage of null value is too low. All right, or maybe too, rather I should write significantly low. Then we can proceed with this. All right, so now I'm going to drop on gender and height. So df dot drop na, and drop na I'll be using the subset, and what all columns do I need? I need to use gender, and then I need to use height. Correct. So once I've used gender and height, next what can be done? I just have to write in place is equal to true. In place is equal to true. All right, this is done. So now if I run this, so now I shouldn't be getting any null values even in gender and height. Let's check this. So guys, clearly now we don't have any null values in gender and height. So this is how, let's say, we can apply. This is when we have to drop the rows containing the null values, used when the percentage of null values is too or significantly low. So this was the first approach that we have discussed. The second approach is drop the columns containing the null values. Let's see how we can drop the columns. So we have to see how to drop the columns containing the null values, right? So let's check this. This is the second approach. This is the first approach. So when are we supposed to use this? This is used when a column contains, let's say, very high percentage of null values. All right, for example, maybe 80% and above, or maybe 70% and above null values. That is when we can drop the column that contains the null values. So this method is, let's say, kind of least used, because majority of data that we might have could be significant, right? In case we do have some redundant columns, then we can drop them. For examples, what all type of columns can be dropped? So we can drop columns such as employee ID, customer ID, because no analysis is done onto them. They're only meant to act as the primary key, right? They're only meant to, let's say, identify a particular customer or employee. So any kind of registration number, all right, certification number, institution number. So all these things can be dropped as the column because we don't perform any analysis. All right, so means it's not mandatory to drop. We can simply exclude them as well. So how to drop the column? So currently, if I consider df, so there is only, let's say, let's try to drop all the, maybe all the columns where the percentage of null value is more than 13. All right, I'm going to drop all the columns that contains 13 or higher percentage of null values. So the columns are job, score, and city, right? These are the columns. Let's see how to drop them. So job, score, and city. So I just need to write, so drop columns. What are the columns that we are going to drop? Job, score, and city. So df dot drop, I need to drop job, then I need to drop score, then I need to drop city. So I have to mention along access1 and in place is equal to true. So drop function is used to drop the rows or columns. Currently we are dropping the columns. Why are we dropping the columns? Because these columns contains let's say comparatively high percentage of null values, but actually this percentage should be much higher, as in maybe particularly maybe more than 70% or even 80%, right? Then ideally we should drop this, but considering the fact that I have to demonstrate an example, this is what let's say we can work around. So now it has been dropped. So now if you check this, there won't be any null values, right, in these three features. So even if I check the data frame, see, now we are no longer left with job, score, city, gender, height. These columns are gone. Job, score, city, and gender and height would remain because we haven't dropped the columns, right? But we have only deleted the rows. So guys, this is what we are left with. So these were the first two approaches. The first two approaches were to drop the rows containing null or drop the columns containing null. Now moving on to the third approach, which is imputation. So we have to identify if the feature is categorical or continuous. For categorical, we can fill it with mode, all right, or some other unknown value. And if the feature is continuous, we can impute it with mean, median, or fixed some integer float, or even apply the interpolation approach. Let's see this. So now I'll be using the second data frame, maybe df2, df1. All right, so over here I'm writing imputation. missing value imputation. All right, so missing value imputation, first we'll go for categorical features. All right, first I'm headed towards the categorical feature. So let's see this. So what are categorical features we have? We can extract it like this. So I'm using df1 dot d types, where df1 dot d types is equal to object, all right, dot index. So now if I print the categorical columns, these are the categorical columns that we have. Now let's means I'll show you in couple of columns. So first let's check gender. All right, I'm checking gender on the gender column. I'm applying value counts. Okay, first let's explore maybe city. First I'm going for city. So this is df1. Yes, see, these are the cities containing null values. All right, means these are the cities that have, this is the count. For Los Angeles we have 13 records, for New York we have 12. So this is the function of value count. I can apply for education. So for education we have masters, then we have job. So this is df1 job dot value counts, right? So how to fill the null values? Let's see first for job. So for job, clearly the mode is teacher, because teacher contains the majority values 11. So it's, let's say it makes more sense to fill the null values with mode for the categorical columns. So, and this is marital status dot value counts. All right, so for marital status, divorced has the highest let's say records, then followed by married and single. So first let's proceed with job. So how do I fill the job? So over here I can write job dot, the function used over here is fill na, job dot mode. And when we're writing mode, it's let's say it makes sense to write 0. Why 0? Because mode simply returns a series. If I don't write 0, I'm getting a series. Now from this series I want the value at the 0th index, right? That is why I need to write 0. So I'm filling it with, see, in the job column I'm filling it with mode of job, and then I'm reassigning this transformation to the original job column. All right, so this is how I've treated the job column. Next I can also treat, maybe let's say, okay, let's go for city. For city, let's say I'm imputing it with, because city there is no much difference between Los Angeles and New York, so it's better to fill it with some other value. So instead of mode, I'm directly going to apply other. All right, and I'll be applying the same procedure for education, because masters bachelors has highest 10. So this is education, even in education I'm going to fill other, and then we are left with gender. Okay, so city, education, job and marital status are done. Then we can check for gender. So if we apply gender dot value counts, what am I getting? Male, female, other. All right, gender, so it makes more sense to fill it with other when the gender is not known, right? And other is already present as a value. So even though the mode is let's say it is bimodal, but still we can go with other. So even for gender, we are going to fill it with other. All right, so guys, now if we check df1, how many columns were there? Gender, city, education, job and marital status. We have treated 4. All right, gender, city, I think we have missed education. So let's check what is the value for education. So if I check education dot value counts, so currently over here we can fill it with mode, right? So this is education and I'm filling it with mode. So guys, this is even treated. Now all these columns are treated. So now none of the categorical columns contain the null values. We can check this. So in df1, over here I had to check for df1, right? So this is for df1. Now in df1, if I check this nvdf, the function that I've used over here, if I apply this for df1, there won't be any null values in these features. See, job, city, education, gender, okay, education I think I've treated. So what is left? I think marital status is left, right? So this is where we have the marital status. Let's treat them. Let's treat this. So this is marital status, and for marital status currently I'm going with divorced, the 4th one. All right, let's run this, and this is done. So as you can see, these features do not show up. Which features? Job, city, education, gender, and marital status. Now the fourth option is to, let's say, treat null values for continuous features, right? So for continuous, we can fill it with mean or median. So first of all, let's say I'll be writing this for df. This is over here I'm writing df2. This should be df1. All right, now we don't see these columns. See, job, city, education, gender, and marital status you won't find here because we have already treated them. Now for df2, all these features are there. First of all, I'll be extracting the features that are numerical. So for numerical features, what can be done? I can simply write like this, and instead of cat calls, I can write num calls. This is num calls, and this is not equal to object. All right, so all these are numerical. So let's say for age, I want to fill it with dot mean. All right, age I'm filling it with mean. Then income I'm filling it with income, again mean. Then score with median. All right, score with median. And height with again median. All right, so this is the height. Currently I'm just treating the 4 columns, right? So this is how I can fill it with mean and median. Then we have expenses. So maybe for expenses dot, I can simply apply interpolate, and I have to save this in the expenses itself. All right, so this is how it can be done. All right, so now if I check this, so except for debt, all the columns we have handled. So even for debt, let's say, let me fill it with some debt value. I'll fill it with some fixed value, right? So fill NA maybe 0. So guys, now all the numerical columns are handled. Now if I run this, you won't find these columns. So guys, as you can see, we have okay, this is in df2. I have to apply it in df2, right? This has to be applied for df2, and even this has to be applied for df2. So let's run this, and even this. Now these columns you won't find. We have job, city, education, marital status, and gender, and they are all categorical columns, right? So this is how we can treat the null values in numerical and categorical data. Next, moving forward, let's understand how to let's say detect and delete duplicates. So over here we do have couple of records that are duplicates. So how can we treat them? So first we have to detect the duplicates. So df dot duplicated dot sum. The data frame name is ddf, right? So this is ddf. Now it contains 3 duplicates. How can we drop them? ddf dot drop duplicates, and then I can mention in place is equal to true. All right, then I can mention in place is equal to true, and then if I check this, so now if I check any duplicates, so there won't be any duplicates. So guys, that brings us to the end of this session. So let's switch to the PPT. So guys, in this session we have understood how to handle missing values, and we have also understood how to handle duplicate values. So moving forward, in the next session we shall be discussing about encoding. We shall be discussing about, let's say, type conversion and normalization. Thank you.